In this video, we try to solve the question, make some contiguous subarray. Okay, so what is given in the question? We are given a contiguous, we have to find a contiguous subarray within a given array A of length n. So basically, what is a subarray? A subarray is a contiguous part of an array. Let's suppose this is an array. This will be a subarray because it is a contiguous part of the subarray. And what we have to do, we have to find the maximum sum of subarray that is contained in that array. So one thing what we can do, we can find all subarrays that are contained in an array, that are basically how many, the number is n into n plus 1 divided by 2. These many subarrays are contained in an array of length n. Okay, well, and what we can do, find its sum. We can find its sum, and after finding the sum we can compare the sum with the other subarrays and return the maximum one. But this approach requires a order of n square time. Minimum is order of n square time. So we cannot afford that much time complexity. So we try to solve this question in the minimum time. So we take these two test cases, 1 2 3 4, 1 2 3 4 and minus 10. 1 2 3 4 and minus 10. If 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 the array only contained positive elements, that means only the positive elements that are greater than 0, we can do it with sliding window easily. We can do it with sliding window approach to solve this question, that in this array we contain the positive as well as the negative element. We're gonna solve it with Catania's algorithm. Okay, we we're gonna solve it with Catania's algorithm. Okay, so how will we solve it? We're gonna find at every element, we're gonna find its prefix sum, and what we're gonna do, we're gonna check if the current sum while iterating over the array, if it become less than the current element, we're gonna update the current sum with the current element. So let's suppose our current sum is uh, initially 0, and we are iterating over this array A. We are at this element, we're gonna add it in our current sum become 1. Okay, current sum become 1. Now we're gonna check if the value of the current sum become less than the current element. If it become less than the current element, we're gonna update the current sum with the current element. Okay, and every step we're gonna calculate the maximum contiguous maximum sum of the subarrays. At every step we're gonna check it. Okay, so at this step mx will be updated to 1, and current sum will be 1. We want to move to next element, we want to add it in our current sum, it has become 3. We're going to check if the current sum, that is 3, is less than 2. It is not, so we're going to update the max sum. Our max sum now become 3. We're going to move to next element, add it to prefix sum. Now it has become 6. Is 6 less than 3? No, it is not. We're going to update the maximum. Maximum now becomes 6. We're going to move to next element, add it to our prefix sum. Now it has become 10. Is 10 less than 4? Is 10 less than 4? No, it is not. So now again our maximum sum will gonna update. Now it has become 10. Move to the next element. It has become 0. The prefix sum becomes 0. And is 0 less than minus 10? No, it is not. So we're gonna, okay, in this step we don't gonna update our maximum sum because in 10 and 0, 10 is greater. Okay. So at the end, after iteration of this whole array, we're gonna return the value of mx. Okay. So let me run through one more test case. That is this one. Let me copy it here. -2, 1, -3, 4, -3, 4, and -1, 2, 1, -1, 2, 1, 5, and 4. Okay, -5. So this is our new test case. Let us analyze this. Initially our current sum is at 0. Okay, current sum is at 0. We are at this element. Our mx is into, because we have to return the maximum. So we loop over this array. Currently we are at this element. We're gonna add it into our current sum. It become -2. Is -2 is our current sum less than the current element? Is it so? No, it is not. So we don't gonna update our current sum with the current value. I'm gonna write it here. If the current sum become less than the current element, we're gonna update our current sum with this element, and at every step we want to check for the maximum value between the mx and the current. Okay, now our current sum is -2, and our mx is currently at -2. We move to the next element, add it to our current sum. It has become -1. Is -1 less than 1? Is -1 less than 1? Yes, it is less than -1. So we're gonna update our current sum to the current element. Our current element is 1. Our current element is 1. Now we're gonna update our maximum sum with 1. Okay. Now we'll move to the next element. This one. Add it. It has become -2. Is -2 less than, -2 is less than -3? No, it is greater than. So we don't gonna update the value of the current sum, and the value of the max sum is also don't update it. We move to the next element of the array, that is 4. We're gonna add it into our current sum. It has become 2. Is the current sum, that is 2, is less than the current element 4? Yes, it is. We're gonna update our current sum with 4, and we're gonna update our maximum sum with the maximum value of the current sum, that is currently 4. Okay, okay. Now our current sum is 4. We'll move to the next element, that is -1. Add it to our prefix sum. It has become -3. The current sum has become, sorry, it has become 3. Is 3 smaller than -1? No, it is not. Will the maximum sum gonna be updated? No, it is not, because currently we are having 4 and the current sum is 3. We don't wanna update. We move to the next element, that is 2. Add it to our current sum. It has become 5. Is the current sum 5 less than the current element? No, it is not. So will the maximum sum will be updated? Yes, it will be updated, because currently the maximum sum will be 4, and the maximum of 4 and 5 will be 5. So our maximum sum will be updated. We'll move to the next element. It is 1. We're gonna add it to our current sum. It has become 6. Is 6 less than the current element 1? No, it is not. Will the maximum sum will be updated? Yes, it will be updated. Now our maximum sum will become 6. We move to the next element. Add it to our prefix sum. It has become 1. Is 1 less than minus 5? No, it is not. It is greater than. Will will the maximum sum value will be updated? No, it is not, because 6 is greater than 1. We'll move to the next element, that is 4. We added to our current sum. It has become 5. Is 5 less than 4? No, it is not. So what we gonna do? We're gonna check between the values 4 and 5, which one is 4, 6 and 5, because the current sum value will be 5 and the maximum sum is currently 6. We're going to check for the maximum between these two values, so we'll get the maximum as 6. Our array is, we have looked over the whole array and we have found the maximum subarray sum as 6. Is it so? Yes. Is it? And for the previous one we have found the answer is 10. Yes, it is 10. So now I will write the pseudocode for it. Okay. So what is the pseudocode? We are taking a variable, that is the current sum, that is initialized to 0, and a maximum sum, which is our answer, that is initialized to min value. Okay. Now we loop over the array. Let's suppose our array name is A. We loop over the array and it has the size n. So we'll loop over the array and add and find the prefix sum using the variable current sum. If the current sum become less than the current element, we're going to update our current sum value with the current element. Is it clear? We're going to update the current sum value with the current element, and the last step of every iteration is we're going to update the maximum sum value with the maximum of the current value in the mx and the current sum. At the end we want to return mx. So this is the pseudocode for the maximum subcontiguous array. It is an important question based on Cadena's algorithm. It is just a modification of Cadena's algorithm. Okay. So if you have any doubt, please feel free to ask. Okay. And keep going.